तो हेलो गाइस, आज हम देखने वाले हैं ऑपरेटर और उसके डिफरेंट टाइप क्या क्या होते हैं। तो सबसे पहले आपको ऑपरेटर बताना। सो लेट्स सी लाइक ऑपरेटर इज व्हाट इज ऑपरेटर। सो ऑपरेटर इज जस्ट अ मैथमेटिकल रूल, ओके, जस्ट अ मैथमेटिकल रूल विच रिप्रेजेंट द एक्सटर्नल एनर्जी फॉर मेजरमेंट ऑफ एन ऑब्जर्वेबल। लाइक हम किसी भी ऑब्जर्वेबल का जो मेजरमेंट देख रहे हैं, तो व्हाट विल बी द मेजरमेंट, ये कौन बताता है हमें? ऑपरेटर। ओके, व्हाट विल बी द मेजरमेंट, इसके बारे में ऑपरेटर बताता है। नाउ इसको रिप्रेजेंट कैसे करते हैं? तो व्हाट इज द रिप्रेजेंटेशन? लाइक ऑपरेटर को हम जनरली कैप से लिखते हैं। लाइक ए ऑपरेटर इज लाइक ए वेक्टर, पी मोमेंटम ऑपरेटर इज पी कैप, लाइक दिस these are momentum operator. Now after operating on a state, like there is a psi, we are taking example, okay, a is operating on the psi state, kid psi. So it can be like two situations there, that it is giving an eigenvalue and the psi state is same, and another is it is giving an eigenvalue and the state is also changing, like it is converted in psi. So there are two possibilities. One is that key that state is changing, another is that state is not changing. Okay, that's called the operator. Okay, now we are going to types of operator. So there are different types of operator are there, like many types of operator. So we will see what and like possible operators to see in the quantum mechanics. Okay, so for net we have like 8 or 10 types of operators. So first of all we will go by basic. Okay, at first we have the linear operator. What are the linear operator? So just for basic understanding, I am saying you the linear operator is just like which follows some property. The A operator is called a linear operator if it like follows this identity, A psi 1 plus A psi 2. Basically this is linearly like is applying on a particularly equal, like it is applied on the particular psi 1 and psi 2 and give the same value of the psi 1 plus psi 2 applied by A. Okay. And the next property for the linear operator is A psi, and you can get out the eigenvalue and after apply this. Okay, so that's the same. This is the linear operator basically. Second operator is identity operator. So what is the identity? Like you all know, like in the basically we see the identity matrix and identity matrix and identity operator are the same understanding. Okay, like I'm saying that I is applied on the kth psi. So if the state is same, and eigenvalue is 1, like same, then it is called identity operator. Okay, this is very simple. In the third operator we are saying null operator. Okay, so what is the null operator here? Let's see, understand. When any operator applied on the psi state and gives a zero value, then it's called null operator. This is called null operator because it's giving zero value. Okay, zero eigenvalue. And the fourth one is adjoint operator. Okay, adjoint operator. So basically adjoint operator are that, like we are saying for this operator A and B, such that we are taking some two operators like A and phi star psi dx is equal to, and like here it will be phi star and B psi into dx. So here what is happening, if A dagger is equal to B, okay, so we will say the B is adjoint of A. Adjoint is what? Adjoint is just like we are transposing the operator plus conjugate. So adjoint is what? Transpose plus conjugate. Okay, so that is the adjoint operator. Now we are going to fifth operator, which is a Hermitian operator. Hermitian operator. So you all know, like in the quantum mechanics, this is a very basic thing that A operator is called Hermitian if the A is equal to A dagger. Basically, this is the rule here. So how will you know in that A is equal to A dagger? So that's a property. Like if A psi whole star into phi dx is equal to somehow psi star into A phi, okay, then it is called the like A is equal to A dagger. Okay, because in here like A is operating and the psi star, if we got this type of form, so this is called A dagger. Okay, this is called a dagger. It means a dagger is equal to a. So this is Hermitian operator. There are many types of that representation of Hermitian operator. That different. I am giving the different example that a and sine and phi. Okay, this is very basic. And if I got somehow sine a phi, so whatever value we are here, it is the adjoint, like it is the Hermitian operator of that and this thing. Okay, so we can say a dagger is equal to b here. Okay, we can say it is a dagger somehow. It will, whenever we change the operator from da to kate, it will convert dagger. Okay, what is the dagger in? Dagger is just Hermitian. Okay, Hermitian. In the next type of operator, there is sixth type, which is anti-Hermitian. Anti-Hermitian operator. Okay. So what is anti-Hermitian? Basically, if you understand like anti-symmetric or symmetric, we see in the matrices. Okay. So in the like in 10th or 11th class, we see the matrices. There are two types of matrices: symmetric matrix and anti. Same type is here. So Hermitian is a dagger is equal to n, and anti-Hermitian is a dagger is equal to minus of a. Okay, like this. So next type is seventh, which is unitary operator. This is very important and like very basic operator, which is used in the time translation, space translation. Many concepts are being introduced by the unitary operator again. So if an operator U behaves like okay, one second. This is object. So if U is an operator such that key U and U dagger are identity, is equal to U dagger and U. Okay, then it is called the unitary operator. So whenever the U dagger inverse and U dagger are the same, that's also the unitary operator property. Okay, it means the operator operators and Hermitian and the operators inverse is same, then it's called the unitary operator. So these are the unitary operator properties. Okay, so no, eighth property, like eighth type, the last one, which is the projection operator, which is the projection operator. So what is the projection operator? So basically, if an operator P follows two, like P is P dagger is equal to P, that should be the first rule. And second for this is P square is equal to P. If these two conditions are followed, like two conditions are satisfied, then it is called the projection operator. Okay, any type of operator which is following these two two properties, then it is called projection operator. So now we have the like and we are solving some basic operators. Like first of all, we will see what is the momentum operator and how you will like find it. So momentum operator. So basically, momentum operator is well-known operator. If you know what is the value of this, I'm giving value minus iota h cross del upon del x, or we can say directly minus iota h cross del vector in 3D. Now, we know what is the value of momentum operator, but what is the derivation of this? We don't talk about the derivation, but you should know how we derive this. Okay, so let's see. We are taking an arbitrary wave function like e to the power iota kx. Well, basically, we are taking this plane wave. Now, a e iota k is what? K is simply p upon h cross. You know this thing. But this is wave vector and this is momentum. Okay, this is related now. K is equal to p upon h cross. So we are putting p x over h cross simply. So now, if you are derivating this state, so del sine over del x is equal to k. What is the coefficient here? X coefficient is iota p over h cross into e to the power iota px over h cross. That is basic. What is this? This is sine. So it is converted into iota p over h cross into sine. So one thing is that sine and sine, if I cancel out, then p and like okay, don't cancel now. Let me cancel. Like what's the value of p psi? So p psi is equal to like h cross over iota. It will go in the next side, and here del psi over del x. Now you can cancel up easily. So p operator is just iota is come out here and minus sign, because 1 upon iota is equal to what? Minus iota. We are using this here. So minus iota, h cross and del over del x. this is the momentum operator in one dimensional, because we are taking one dimension function. Okay, now we will find this operator in the 3 dimension for the spherical wave. Okay, in 3 dimensional wave, like how to find? We are taking an spherical wave function. Spherical wave function. Okay, so for that we have psi r is equal to e to the power minus iota here. That's simple. As the taken for spherical wave, there is an r also. Okay, so a e to the power minus iota pr over h cross divided by r. Simple. Now, what is the value of del psi r over del r? We are derivating this. So, a is the constant here. So, minus 1 upon r square. We are derivating 1 upon r and constant assuming this, and plus we will derivate this term, and 1 upon r is here constant, like minus iota p over h cross. You can see, and e to the power minus iota p r over h cross. Very basic differentiation is there. Okay. So what is the del psi over del r? Now we are getting minus 1 upon r and plus iota p over h cross. I taken the common, like a e minus iota p r over h cross into 1 upon r, because this is our wave function. So I taken common out is, so minus 1 upon r plus iota into p upon h cross into psi. Now you know what is the this size cancel, basically this size cancel. So what we will get, del upon del r is equal to minus 1 upon r plus iota p over h cross. So what is my momentum operator here? My momentum operator is being h squared upon iota 1 upon r plus del upon del r. Okay, so this is my momentum operator in 3 dimensional for spherical wave. The one form is left, which is cylindrical wave. Okay, we are doing that also. So in cylindrical fan momentum operator, how we will derive this? Okay, momentum operator. So let's see. First, we will take a cylindrical form of the wave function. So psi r is equal to a e to the power iota k r and upon root r. The cylindrical and spherical waveform are same, but in cylindrical there is root r, and in spherical there is r value. Okay, so what is the differentiation? We will do the same thing. Here is also we will do the differentiation. So I am writing directly what is the differentiation. We will get 1 upon 2r iota p over h cross a e to the power iota pr over h cross. We have just put it k is equal to p upon h cross. Okay, don't mind, you can check it. Okay, and root r. So after that we will get minus 1 upon 2r. Okay, there is side, and there is I think plus some, because we will derivate this now. So there should be plus term. Minus 1 upon 2r iota p over h cross. Now we are getting psi here, del psi over del r. Psi is cancelled. But we are getting, let's see, del over del r. This will be coming out, I think, minus 1 upon 2r plus del over del r. Now, what is the momentum operator value? One thing, I had done something mistake. There should be iota p over h cross, because I taken this in this side. Okay, so okay, this is right. P value is minus iota h cross and 1 upon 2r plus del over del. This is my momentum operator in cylindrical form. So today I discussed some like operator, what are the types of operator, and momentum operator in 3 types, like how to derive the momentum operator in general form, like 1D and spherical and cylindrical form. Okay,